All right, welcome back. So we'll start tonight off with just a couple review problems. These actually fall under the A-B category, but they're all pretty decent questions. So we'll just take about, I don't know, 6, 7 minutes and we'll run through three different questions that almost certainly you'll see on the AP exam. So I think they're worth doing. So I will let you guys tackle this first one, take about 2, 3 minutes, and then I will post an answer to it. So off you go. Okay, we should be getting close there. So hopefully we're talking about L'Hopital's rule. Couple things. If this is in multiple choice, remember, it doesn't matter what you do. I mean, it matters what you do, but it doesn't really matter what you write in terms of notation. If this question was in free response, the first thing you want to do is you have to show it individual limits. So if this was free response, you should say the limit as x goes to pi for the top piece and say that that's equal to 0. The limit as x goes to pi for the bottom piece is equal to 0. And then you write by L'Hopital's rule and then execute the rule. If it's multiple choice, we don't want to do any of that. Just start doing the rule and off you go. In doing the rule, we should have come up with, so when you take the derivative of the top piece, you can see what you've got, and then of the bottom piece, and that should work itself out to 0. Does that make sense? Okay. All right. So the next one we'll look at is the graph of f of x is shown to the right. So this over here is the graph of f of x. Let g of x equal x squared plus x minus 1. And let h of x equal the following. This is called a composite. Find h prime of 1. And this is, you're going to be taking the derivative of a composite. You've got a function for g and you've got a graph for f. Off you go. Okay, so here's what I've come up with. All right, so your derivative would be f prime g g prime. That's the definition of a composite, right? So the composite derivative is f prime of g times g prime. And then we want to put a 1 in. So we need to find g of 1 and g prime of 1. So g of 1 would be 1. That's from plugging in up here. G prime of 1, we need to find g prime, which is the derivative. G prime of 1 would then be 3. And then we need to locate f prime of 1. Well, how do we locate f prime of 1? That's going to be the slope of this line, which is 5/3. And then 5/3 times 3, that should give you 5. Okay. All right. And the last one for today. The table gives selected values of differentiable and of a differentiable and increasing function f and its derivative. If here's the whole key to this, if g is the inverse of f, what is g prime of 1? So we need to know the derivative of an inverse formula. This is definitely on the AP exam. So these are all three of these are pretty much 100% on the exam, so they're worth looking at. Find the derivative of the inverse, use the table to find the information. Okay, we should be coming up with, here's what I got. So our formula is g prime is equal to 1 over f prime g. We're looking for g prime of 1, so we need to locate g of 1. What do we know about g of 1? Well, we know on the table that f of 2 is 1. Therefore, g of 1 is 2, because that's how inverses work, right? We can flip-flop the points. So now I know g of 1 is 2, which means I need to find f prime of 2. And we have that in the table here. F prime of 2 is 4, and therefore that would give us 1/4 for an answer. Okay. All right. So that's just a little warm-up review. Let's take a peek here. From last night, we said here was the important information. If we are going to go from rectangular to polar, we said that we were going to know that r was going to be equal to the square root of x squared plus y squared. And we said that arctan of y over x was going to give us our theta value, and that polar coordinates are in the form r comma theta. Okay. If we want to go the other way around, then that would look something like these. And then we did all, you can refer to the previous video of going each direction with these. Okay, tonight's lesson is going to be, we need to take derivatives of this stuff. So let me just give you a second to process this. All right, now, some of this is optional. Let me explain what we have here. So you can copy it down. This is how it's written in a textbook or on the internet, or basically what this is whenever we're going to take the derivative of something involving polar, it's going to be the derivative of the y piece over the derivative of the x piece. But now remember what we have for polar. The x piece is r cosine theta. The y piece is r sine theta. So these are both product rules. And when we get into these formulas, they give you a formula for r. Okay. And so the way they define these in books and on the internet and stuff is that they say it's r is a function of theta. So they say let r equal f of theta. To me, that's optional. I think you could survive without it. We'll kind of talk more about that as we go. I'm just going to stay quiet for a second. This is a lot to copy. But what you're copying down is essentially a product rule of each. It's the derivative of the y piece over the derivative of the x piece. And each of these is just a product rule being executed. Okay, so let's kind of go look at one of these in action and we'll see what we can come up with this. We'll talk through it together. So I'll let you copy this down. It says R is 1 plus cosine theta. We want to find dy dx and the slope of the tangent line. So in other words, we're going to plug in pi over 6 to the derivative when we are done. So we have the R value. Now, this is all they provide you with, but I think you should put some other information down here before you get started, just so you know what you're doing. So that is that our derivative dy dx is going to be equal to dy d theta over dx d theta. Okay, so now we got to talk about what this means here in this notation. If we're finding, let's just look at the top piece individually. If we're finding dy d theta, this is like implicit. So anytime that you, the bottom right letter of what we're finding is an x. So anytime you derive something that's going to have one of these thetas, we need to tack on and see what we come up with. So the formula, I'm trying to see what we have here. So R is equal to 1 plus cosine theta. What else do we know about this? X is equal to R cosine theta, and Y is equal to R sine theta. All right, now, what are we taking the derivative of up here? We're taking the derivative of dy d theta. So that's going to be this piece right here. So it's going to be a product rule. So the first thing we're going to do now, this whole piece up here about this, I don't know that I like this actually, as I talk myself through. That's how it's written in a textbook. but anyone that's, you're familiar with my teaching, I don't do half of what's in the textbook. I think this is more confusing. We'll see what you guys think. I don't know. So it's going to be first. So the first is just R, right? So just copy it down. We don't need to write this other notation in there. I don't think we need a placeholder. It's just going to be 1 plus cosine theta. That's your R. So first, and then we're going to do what? We're going to derive the second. Remember, we're taking the derivative of this up here. This y is r sine theta. So derive the second. Sine, the derivative of sine is going to be cosine theta. First derive the second plus the second. And then if we derive the first, what are we taking the derivative of? We're taking the derivative of r, and that's going to be the 1 is out of there. That's just going to be negative sine theta. I think that that's easy enough to just keep track of. We don't need any placeholders or anything in there. Okay, so do the same thing now. Take the derivative of the bottom. Now we're going to be taking the derivative of the x formula, which is r cosine theta. Okay, so this is going to be first derive the second plus the second derive the first. So what does that give us? Go through and see what you come up with. Did you guys come up with the same thing? Okay, so you've got your derivative right there. And now all they're asking us to do is to plug in pi over 6 into all of these. So pi over 6 is 30 degrees. At 30 degrees, the ordered pair is root 3 over 2 comma 1 half. So let's go through and do that. This would be 1 plus root 3 over 2. And then this will be times root 3 over 2. Some tedious calculations here, unfortunately. What are you guys coming up with here? This is kind of messy. Did you have to double check all these calculations, truthfully? Um, I think when they give you one of these on the BC exam, I think it would be way more. Um, I think they would pick something like pi over two or something where things would just drop out real quick. I don't think you would see one quite this crazy. The important piece to this is right here, and that is that this formula makes sense. So do you guys have any questions on that actual formula there? No. Okay. All right, let's have you try again here and see what we come up with. So find the slope of the tangent line when theta is equal to pi over 3 for r is 1 plus sine theta. Okay, off you go. Okay, so as we're starting with this one, um, we're going to be taking the derivative of the y stuff. So it's going to be first, which is r, derive the second, plus the second, derive the first. And then for the other one, it's going to be, we're taking the derivative of our cosine theta. So that's going to be first, r is 1 plus sine theta. Derive the second, plus the second, derive the first. All right, does that derivative check out for everybody before we go any further whatsoever? Okay, I see a thumbs up. All right, you have options here. Maybe it's helpful for you guys to stick to the trig things first. So in other words, we could call this, just showing you an alternate way of doing this. If we kind of distribute this out a little bit over here, you could call this cosine theta plus sine cosine, those each have thetas, plus sine theta cosine theta. And then on the bottom, this would be negative sine theta minus sine squared theta plus cosine squared theta. So you can do that kind of math before you plug in if you think that would make anything easier for you. When I went through and did this earlier, I came up with -1. See a couple thumbs up in the crowd. Okay. So the important part is that you are this derivative is making sense. After that, kind of is what it is. All right, so to wrap up tonight, I'm going to have you guys, this is for the same problem. Find all vertical and horizontal tangents. So if we are going to be looking for, we'll say the horizontal over here, and then the vertical over here, we got to do some trig stuff whenever we're going through this. So horizontal tangents means to set the top of the derivative equal to 0. And when you see what I came up with over here, this is going to be important now. Sine cos and sine cos, those are like terms. So we're going to say cosine theta plus 2 sine theta cos theta is equal to 0. And on the other side, what are we going to have there? This is negative sine theta minus sine squared theta plus cosine squared theta. And we're going to set that one equal to 0. So there's some tricks to these. I mean, this one on the left is pretty straightforward. You should be able to GCF that, set them to 0, solve, no problem. Over here, so it's negative sine squared. So sine squared plus cosine squared is 1, but that trick doesn't work here because this is a negative. The only thing that I can come up with you guys can do here is you could make a substitution for the cosine squared. So if you make a substitution and get all of these to be sine, then you can make some stuff work. So what are we able to actually substitute for cosine squared? We should know that sine squared plus cosine squared is equal to 1. So you're allowed to say that cosine squared is equal to 1 minus sine squared. And then if you make that substitution into here, then you've got a thing that'll factor and it'll work its way out. So this is going to be negative sine theta minus sine squared theta plus, and now instead of this, we're going to call it 1 minus sine squared theta. And then when you go from there and do some like terms and what have you, things should work itself out. All right, so I'll stay quiet for a few minutes. You guys can work these out, see what you get. So for the first one, we can take out a cosine theta. That leaves us 1 plus 2 sine theta. And setting these equal to 0. Cosine theta is 0. And then over here, this would be sine theta is negative 1/2. And then we need to go answer where at for these. So this would be where is cosine theta equal to 0? That would be pi over 2, 3 pi over 2. Where is sine equal to negative half? That is 7 pi over 6, and at 11 pi over 6. All right, for this other side, so I see like terms here and here. So negative sine theta minus 2 sine squared theta plus 1. Okay, so just personal preference. This is going to be something that's factoring, but I don't like to factor when my leading term is negative. I think that's messy. So I always try to do whatever I can to get out of that. So in this case, I'm going to throw all of these terms to the right. And now that would be 0 is equal to 2 sine squared theta plus sine theta minus 1. And now that looks a lot friendlier because I can say, oh, okay, that's something that factors. I'm used to that. And then to factor that, that would be 3-term factoring. So 2 sine and sine, 1 and 1. What are we trying to make in the middle? A positive sign. So that would be a plus and that would be a negative. Does that check out when we go through? 2 sine times sine is 2 sine squared. That's going to be plus 2 sine minus sine. Yes, that completely checks out. So then we would set each of these equal to 0. And solving that, that's going to be sine theta is equal to 1/2. Sine theta is equal to negative 1. And then that would give us answers at pi over 6, 5 pi over 6, and 3 pi over 2. So key takeaways for tonight is that we know the formula and the setup for taking the derivative of something with polar. Then you take your time, do your best with the math. If you're doing horizontal verticals, horizontal is set the top to 0, and vertical is set the bottom to 0. Does anybody have any questions? Okay, so that's about half of the information on the topic of polar. I would expect there to be probably a part 3 and 4 on polar. And then after we wrap that up, because there's some free response stuff that gets a little messy. There's usually a polar free response question. So we'll be going through some of that. And then once we wrap up the polar lessons, I think that'll be so Thursday and then Sunday should take care of that. Then we are on the home stretch. The last unit in BC is called Sequence and Series, and that's a whole adventure as well. And then that's it. So if we wrap up looking at my calendar, by the 14th, we ought to be done with polar. And then truthfully, the sequence and series stuff takes a while. By the end of April, though, I think we've just about got it. We'll be super close. And then there's still a week or two after that. So we can do some review sessions. I'll post some practice exams. I'll post some college board videos. As long as, the stuff in class with Nickley's making sense and the majority of this, remember, don't forget your test is still like 70% AB. So focus heavily on what's going on in school with Nickley. And then we're going to just do our best to make sense of the BC stuff. And as long as you ace the AB stuff, which I think you guys are going to, and then do reasonably okay on the BC stuff, you're going to get a passing score on the exam. So hang in there. We got about a month left. I will see you guys on Thursday night and we will keep chugging away at polar. So have a good week. I will see you guys on Thursday.
Yeah.